Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Whole Lotta Lots by GDC. Or, yeah, I guess that's the play on a lot of holes. A lot of whole holes? A lot of whole holes. Whole lot of lots. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means that every cell in the grid place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell regions, which is a box. We have holes, where we need to place 9 black holes, 1 in each row, column, and box, and digits may not repeat on black holes. We also need to place 9 white holes that follow the same restrictions. So there are 9 black holes, 1 in each row, column, and box, and there are 9 white holes in each row, 1 in each row, column, and box, and you cannot have repeats in the black hole cells and the white hole cells. And white holes and black holes never share the same cell. So you can't have a white hole and a black hole in the same cell. You can only have either one white hole, one black hole, or nothing, period. We have teleporting little killers, where clues outside the grid give the sum of digits along a diagonally traveling path starting in the cell pointed at by the arrow. This path only ends when it reaches an end of the grid. When the path enters a black hole, it teleports to the white hole with the same digit, maintaining its direction, including both holes in its sum. The path may only visit white holes by teleporting to them. So, as an example, say you had a black hole here, and it was, I don't know, a 5. Then the sum of these digits here, let's say the white hole that was 5 was corresponding here. Let's make it red and blue because it's easier. Actually, let's make it dark and medium gray. So we're making this 5 and this 5. So this is the gray square is going to be the white hole. The dark gray square is going to be the black hole. So that means this diagonal would have to be the sum of these 7 cells, because it continues in the same direction going this way from the white hole, and it includes both the black hole digit and the white hole digit in its sum. So keep that in mind. And the path may only visit white holes by teleporting to them. And we have connect the lots. Okay. Each circle must be visited by exactly one path. That path must start from an outside clue with a gray background. So one of these. 6, 12, greater than 0 or greater than 0. They must match the cells that match these circles. And, okay. The circle digit counts the total number of times the path teleports. Okay. And circles may not contain holes. Also, digits may not repeat in circles. Interesting. Interesting. So that means, well, okay, so say, I don't know, say we actually did something like this. This was the white hole of the 5. So then this would go like this, teleport to the 5, and then end that way. And then this would have to be essentially this cell, assuming there are no other teleportations, this cell would have to be a 1 then to match that. That's interesting. Circles may not contain holes, so you can't have a black hole or a white hole in the circles. And digits may not repeat in circles either. So they can't repeat in black holes, they can't repeat in white holes, in the cells in the white hole, and they can't repeat in circles, along with the row, column, and designated 9-cell region for normal Sudoku. Huh. Interesting. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Do we make it dark gray and gray, though? I guess. We'll make blue essentially non-whole cells. Anyways, did I say, yeah, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. First thing that I see is this has to teleport, right? There's no way you can have 9 cells essentially add up to 6 in this puzzle. And it cannot teleport here. It can't teleport in the circle because there's no holes in the circles. So it either teleports here or it teleports after the circle. If it teleports after the circle, this is a minimum of 2, 3, and 1, adding up to 6. But you have to also take into account the digit on the other end of the black hole, which is the white hole, which also adds that minimum 1. So that's 7 guaranteed if that were the case. Therefore, the black hole has to be before the circle. This is not... Okay, so obviously the circles are not black holes or white holes. Therefore, this is a black hole, and it's 1, 2, or 3. It has to go through a circle, because all the circles... Because there are no repeats in circles, and the circles count how many times the path teleports. So if you have one path that is taking 2 circles, it would have to have the same digit for the number of teleports. So this must connect to one of the white holes. And it must go through a circle. So it must go either here, here, or here. So it's guaranteed at least to be 1 or 2. It cannot be 3. If it's 3 as the black hole, the white hole would be 3, and that would be 6 at least. And then the digit in the circle has to be at least 1. So this is 1 or 2. If it were here, this would be 2, 2. Okay, so there are no more black holes in row 1 and column 9. So this cannot be a black hole, but this also has a gray background, so that must teleport also before it reaches the end of the grid. So it has to teleport here. And it goes that way also. Cannot teleport to a black hole, so it cannot include these. So this one must be included by this kilo killer going down that way, or this little killer going up this way. This is at minimum 32. That seems fine. It's possible without any teleportation. Interesting. if each digit has to be different in a circle, that's at minimum 1, 2, 3, and 4, which means there are 10 at least teleportations. Interesting. Okay. Um. Hmm. We know the 6 can only teleport once. If it tried to teleport twice, it would have to have 1 and 2 included in it. Can 12 teleport twice? The problem is, I guess maybe? Hmm. 6 can only teleport once. So that means 12 does have to teleport twice. Huh. Or 3 times. I don't think it can teleport 3 times. 6 cannot teleport twice because that means at minimum, including the black hole and the white holes, that would be 1s and 2 times 2, which is 6. And then you have to have another digit for the circle, which would be at least 2. So that's 8 at least. 12, you would have. So you cannot have. So for 12, the 2 teleportations. The 2 teleportations can only be 12 and 3. Sorry. If we tried to have 2 and 3, because we can't have 1 and 2, because 1 or 2 is the black hole for 6. So if we have tried to have 2 and 3, I don't think that works, right? 2 and 3 added together is 5, multiplied by 2 is 10. And we have an extra digit here. So 10 plus the circle, which it has to go through, is 2. That's 12, and we have an extra digit. So it cannot be 2 and 3. Therefore, for the black holes for the 12, it must be 1 and 3, which means the black hole for the 6 must be a 2. So this must be 2. It teleports to a 2. And then 1, 1. So it could be 2, 1, 1, or 2, 1, 1, or 2, 1, 1. We don't know which. So this can't be 1. It can't be 2. This is 3 through 9. The 1 and 3, you have 4. So, and this can't be 2. So you have 4 times 2, which is 8. You have a teleportation of twice. You cannot teleport 3 times. That's 1, 3, and 4 at least, which adds up to 8 times 2 is 16. So it's already too big. So it must teleport twice. And this then cannot be 3 or higher. If it's 3 or higher, the problem is you'd have already 8 plus 2, which is 10, plus 3 is 13. So this must be 1, and it must teleport to 3. The 3 then goes to somewhere where 3 is not. So this is nothing here. It cannot be black hole. So then we need a black hole to the white hole to another black hole. Or it doesn't have to be. So 1 cannot be either of these. So 1 has to be here. So that means to teleport the 2 must teleport to 2 and 1 here. So this must be the white hole. That's 2. And this is a 1 and nothing. So this is 1. We need... So 1... We need a 3 white hole, and a 1 black hole, and a 1 white hole. Okay. Where can the 1s be then? Black hole cannot be here. Where can 1 be, period, is the question, right? 1 could be here, 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 but not any of these two. One can't be here or here, so 1 could be any of those 4. Cannot be here or here, so any of these 3. The 1 has to be near the edge of the grid. 1 cannot be any of... It cannot be here, cannot be here, so it's one of these. The 1 for the white hole has to be the edge of the grid. Or near the edge of the grid. So I think it has to be here. We need a black hole and then a white hole. So can this be the one? 3 could be a white hole here, and then a black hole 1 could be there. No. So this can't be 1 black hole. Where are the 1 white holes is the question, right? You have 3 and 1 times 2, that's 8. Plus 1, plus 2, we have an extra 1 we need to account for. So that means it could be between the 3 and the 1 black hole and white hole. So could the circle, actually, technically. I don't think it can be here. So I think it has to be here that contains the 2. Okay, this can't be 3 because of 3 in the row. So I think it has to be here as 2. You could technically have 1 there, but then the problem is... So the 1 white hole has to be at most 1 away from the edge of the grid, going to the left and down. Well, that eliminates all of these possibilities. That eliminates all of these possibilities. You could include the circle. So the 1 white hole could be any of these. Or cannot be here. It could be here. Or it's can't be any of those. Because, yes. So it could be 1, 2, 1, potentially. I think this has to be the circle for the 12, right? Because it can't go here, because the farthest the 1 white hole could be would be here. So that'd be 1 extra digit. And there's too many extra digits. We can only have an extra 1 and an extra circle. So this has to be the 1 for 12. It's 2. So I think this has to be a white hole coming out. This is 1, and then you have another 1 here. So this is 1, and it's normal. This is 1, and I think it's the white hole. So 1 cannot be here. 1 can't be any of these. 1 can't be here. So then it goes here. This is normal. So then we have 1, 3, 3, 1. That's 8. Plus 1, 2, 1. That adds up to 12. 1 has to be next to a 3 as a black hole. There are no 3 black holes here. So the one black hole has to be opposite of a 3 white hole. Oh. Well, this could be 3 white hole. This cannot be 3 white hole here because we have a white hole here. So that means the one here or here cannot be the black hole. So you could have, obviously, okay, so where could the one black hole be? Not here and here, because that would require white hole 3 in these spots. Not here, none of these. So black hole 1 cannot be here because of black hole in the box. Black hole 1 cannot be here because of black hole in the box. So 1 here cannot be white hole because 3 has to be here as a... Sorry, 1 here as a black hole that doesn't work because 3 here cannot be 3 as a white hole here because of 3 in the row. So this can't be 1. So one of these is 1, which means one of these is a 3 and is the white hole correspondingly. So we have a black hole in one of these 3 cells, which means these cells cannot be white holes or black holes. These cells can't be white hole or black holes because we have a black hole there. So one of these 2 is a black hole. That's interesting. Hmm. This cell, so what path is this thing? It cannot teleport to here. So that means this must be a white hole, must be going from this direction, teleporting this way. So this must be a white hole here, which means we have a black hole and a white hole in column 1. So this cannot be black hole or white hole. That means one of these is a white hole. So that corresponds to this column. There's no 1, 2. It could be 3, though, up to 9. This is 4 through 9 here. This cannot go through here. So one of these is a black hole. We don't know which. That means it must go through here, but this could actually be this can't be a black hole. So it ends this way. So this is not, that means this must be a white hole. So this is a white hole. I guess it could go this way, right? Enters the black hole 3 there and then goes there. That is possible. So that means this is a white hole, which means none of the rest of the box and none of the rest of the column can be, okay, this is, yeah, gray. Which means the rest of the box and the rest of the column cannot be white hole or black hole. Okay. So it definitely goes to here. So it could go through 3. And in fact, there are, again, some of these teleportations have to be through multiple of these black holes, right? Because you have at minimum 1, 2, 3, 4 teleportations. That's 10. So you're going to have to teleport at least twice through at least one of them, right? Hmm. This is 19 going this way. You cannot enter a white. The paths cannot enter white. Cannot visit white holes except by teleporting. So that means one of these is a black hole. This cannot be 3 or 1. Because of this diagonal, right? If this were a white hole and this were a black hole, it would visit the white hole by going that way, which is not allowed. Okay. You cannot have a black hole in either of these cells, and you can't enter a white hole except by teleporting. So this has to be this has to be a black hole then. Interesting. Which could be 3 and 1. Huh. Because none of these can be black holes and can't be white holes because you cannot enter the white hole by itself. This is guaranteed to be a black hole, though. Huh. So this goes 1, 2, 3, 4, 5, 6. Hmm. 14. So we have 2, 1, 2, and 3. Could this be a black hole? No. We already have a black hole and a white hole in column 8. So these can't be black hole or white hole. So we have a black hole in one of these two cells. Interesting. Okay, so this must add up to 14. It's 5, 9, or 6, 8 here. If there was a black hole in either of these spots, I guess it could enter that way. Yeah, 1 does kind of work if it goes there. Hmm. Okay. So one of these must teleport at least. Okay, so this one. So this one down here. Okay, this one corresponds to this one. So it must teleport at least 4 times. This must teleport at least 3 times. Okay. So this sees both a white hole and a black hole. This sees a white hole and a black hole. So white hole cannot be here or here. That means, oops, white hole cannot be here. This must be a white hole here. Interesting. That means we have 2 white holes and 2 black holes in a white hole and a black hole in row 2. This is black hole here. Oh, this has to be 3 and 1. These are the only places for the white hole and black hole for 3 and 1. And obviously this is the white hole for this row. This is the black hole for this row. So this cannot be 3 and 1. Therefore, this is 3 and 1. Okay. That means 1 is one of these 2 cells. 1 has to be here in column 9 because there's no other place for it because these ones are eliminated there. In row 3, it has to be one of these 2 cells. So it teleports 1, 3, 3, 1, then 1, 2, 1 there. And that adds up to 12. 1 plus 3, and 3 and 1 is 8, plus 1, 2, 1 is 4, is 12. 2 teleporting to 2, 1, 1 is 6. Okay. 3 is one of these 3 cells here. Obviously can't be the black hole. We need to be teleporting a lot. So we go 1, so this goes all the way to 1. It goes here. One of these must be a black hole. Obviously, it could be here. It can never get to 3. So this one, though, has to get to 3 somewhere as a for a white hole. So white hole cannot be here. White hole could be here, cannot be here. So where's the white hole along this diagonal for the 3 to get to here so that it gets to here? It cannot be these. Can't be here for the white hole. It has to be. It cannot be here because we have a white hole in the row and these are normal. So it must be here. So this is a white hole, which means this cannot be 1. So this is 1 here because we can't have repeats in white holes, and this is 1 there. These are normal digits. We have white hole here, so that means these can't be white holes. Where's the white hole in box 6? It must be there. So this is white hole. We need a white hole in row 9. Cannot be here, cannot be here, can't be here, so white hole has to be there. That gives us a white hole that has to be here. This can't be 3 then. Okay. No white hole and black holes in row 4 left. Same with row 1. One of these two is a black hole. This goes this way. You could have a black hole in front of this, so we don't know about that. Oh, this goes to a white hole, so that means a black hole must be one of these 2 cells, which means the rest of the box cannot contain black holes, and we already have a white hole in the box. So one of these 2 is a black hole, one of these 2 is a black hole, because paths cannot enter except by white hole except by teleporting. So one of these is black hole. So we are using, this one uses the 1 teleportation, and this one uses the 1 teleportation. You cannot use the 2 teleportation. Oh. Where is the black hole in for this? It needs to be one of these 2, which eliminates black holes in the rest of the box. So to get from the 1 to teleport more than once, that means this has to be black hole. So this is black hole, which means This can't be black hole, and this can't be black hole, so this must be black hole here, which means this can't be black hole, so that makes this black hole here, which eliminates black hole here, so this is black hole here, which means this can't be black hole. These can't be black holes. Therefore, this is black hole here, no black hole here, which makes this a black hole. Interesting. Okay, so it goes here. This teleports once, teleports twice. Cannot go to here because then it enters nothing. Can't go to here directly. Let's label these white and black holes. So this will be A. We have A, B, C, D, E, and F. And then we'll have Z, Y, X, W, V, and U. Let's not make it capital. Let's make it a small size so we can figure that out. A, B, C, D, E, F, Z, Y, no, Z, Y, Y, we'll eventually get there, Z, Y, X, W, V, and U. So where can these teleport to? We have this going down here. That's one teleportation. This is the second. You cannot go to E. You cannot go to F. You can't go to C. You can't go to D. You can't go to B. You has to go to A. Right? If we go B here, so we go diagonally here to the 1, diagonally here to the U. You can't go B. You can't go D. You can't go C. You can't go F. You can't go E yet. So this must correspond to A. So we have A and A here. So this one teleports to here to go here. Again, if you go B here, it goes to the edge of the grid. If you go D here, it goes to the edge of the grid. C goes to the edge of the grid. F goes to the edge of the grid. Therefore, these must be the same, E and E. Because again, you have to go you have to get to a circle from the gray cells. So 1 teleportation, 2, 3, and that's it. So this is 3. Okay, this teleports that way. This cannot be the same digit as that. So let's work backwards from this way. So we have 1 teleportation here to 3. That means to the C. C cannot go to Y. If we go to V, it just goes back to the edge of the grid. So this can't be V. It could be W. So this could be W. Or it could be, cannot go to B. If it goes to, wait, hold up. We're looking at black holes. Sorry. So it could go to W, cannot be Y or V. Can't be E, obviously. We know this is A. So it's W or Z. Okay. So this is 37. V cannot be the same as C, cannot be the same as F, but could be B or D. But if we go to... Oh. V... to D... So B is problematic. So this teleports here. V is problematic though. I guess it could be. It's 99991. V cannot go to F, obviously. They're in the same box. If you try to go to B, that's 3 digits to try to add up to 37, which is impossible. So V cannot go to C because of the way that works. Also, you couldn't do that anyways because then you would have to go through a white hole. So it has to go to D. And therefore, these 5 cells add up to 37. That means these are all 9. So you have 9, 9, 9, 9, and 1. This cannot be 9. These can't be 9 because of 9s in the row, so this must be a 6-8 pair. Okay. So that's that path. W could go here. That's possible. It cannot go here. So W cannot go here. W could go here, or it could go to B. Those seem... So W can go to B or F. Cannot be F. B or C. Because that would be too few. If he goes to F, it would be just 3 cells trying to add up to 32. 3 digits trying to add up to 32, which obviously doesn't work. So this teleports once, twice, 3 times. This teleports once. So it goes to here then, next, Z. So once, twice. Okay, so it teleports here once, twice. If Z goes to here, so 1, 2. So teleport once, twice, 3 times, and that's it. That's just not possible. So this cannot be Z. This must be W. So C matches there. That means it goes to 9. 9 to Z does not go to B. It goes to F. Right? So teleport to 9. 9 to this one, which must be F. Because it can't be B anymore. So this is F and F. This is B and B. So it teleports to 9 once. 2 for F. 3 for C. 4 to 3. And this is 4 then. So this is 4. So we have 1, 2, 3, and 9 for the black and the white holes. This is 32. Okay. C can be at most 8. Right? So you could have 8, 8, 9, 1, 8, 8. That's... We have a lot of degrees of freedom there. Okay, so that's not helpful. 19 to the F. So we have these twice. So these must be odd digits. Okay, so this... What are these digits possible in box 3, 5, 6, 7, 8? This is at least 11. 5 and 6. So F and F is 4 to add up to 8. So this is 5 and 6 then here. This becomes a 7, 8 pair. So A cannot be 7 or 8. So A, what is A? It is no 1, 2, 3, 9, 4, 9. No 7, 8, it's 5 or 6. Cannot be 6 because of 6, 8 pair in the box. So A must be 5. So these are 5 then. That eliminates 5 here. This is 6, that's 5. So again, the paths 1, 3, 3, 1, 1, 2, 1. And that's 2 teleportations. That adds up to 12. 6 goes 2, 2, 1, 1. That's 1 teleportation. And that's adds up to 6. 19 goes 5, 6, 4, 4, which adds up to 11 plus 8, which is 19. So those 3 are done. This greater than 0 teleports once to the 1, twice through the 5, 3 times through the E. So that's 3, and that matches the circle. This greater than 0 teleports once through 9, twice through the 4, 3 times through C, 4 times through 3, and then it's done. So this is 4. Remaining digits in column 7, we have 2, 3, and 4, and this can't be 2, obviously. So B, C, and E are 6, 7, and 8. We don't know which is which. Okay. Remaining digits in box 9. We have 3, 4, 7, 9. And this can't be 3, 4, or 9. So this must be 7. This can't be 7 or 9 now. So this is 3 or 4, which forces this to be 9 here. Remaining digits in row 9 are 2, 6, and 8. Okay. Remaining digits. Okay, this 4 eliminates 4 here. So this is 3. That makes this not 3, so this is 4. This can't be 2 or 4. This is 3, which makes this a 2. Remaining digits in column 8 are 6, 7, and 8. And one of these is a 7. We know B, C, and E are 6, 7, and 8 also. Okay, so we have a 6, 7, 8 triplet in row 6, which eliminates 6, 7, 8 in the rest of the row. So this has to be E. So this is guaranteed to be E here. Because these are 6, 7, 8 as a triplet. We already have B and C here. This must be E. So we have, what? 4, 5, and 9 remaining in row 6. So 4, 5, 9. This can't be 4. This is 5, 9. This can't be 9, so it's 4, 5. This is B or C. We're not sure which. This is C and E. That's not helpful. B cannot be here. So B has to be one of these two in box 7. This cannot be 6, 7, or 8. So it has to be 2, no 3, 4, 5. This can't be 2 or 4, so this must be 5, which means this can't be 5 here. This is 2 or 4. So these 2 plus these. So remaining digits in row 7 are 6, 7, 8, and 3. We're guaranteed one of these is a 3. This sees C and E. This sees B and C. So E could be here. E actually has to be one of these two. So we're guaranteed E is one of those two. B cannot be here. So B is one of these two here. B is one of those 3, obviously. 6, 7, or 8. Oh, right. Because where's B in row 7, it has to be one of these two. Where's E in row 7, it has to be one of these two. So B and E cannot be here. C can't be here either. So this must be 2 here. So this cannot be 2. This is 6 or 8. And it's a 6 or 8, which means it's B, C, or E. So this cannot be B. Therefore, B's here. And this is C and E here. So that makes B here. So this is B. B can't be here. B can't be here. Where's B in box 6? It must be there. So that's B. C has to be one of these two. And then we're with 4 and 5. So this is B and E. Therefore, this is C, which makes E a 7. So E is 7. So 7 has to be one of these two. So this cannot be 7 here. This is B, C, and E. This must be a 2-4 pair. And this 2 eliminates 2 here, so this is 4, which makes this 2. Okay. We have 6, 7, 8, and 9 remaining in column 2, which means this can't be 7. B and C are 6 and 8. This can't be, this sees both B and C, so B cannot be either of these, so this must be B here. So this is B, this is B, this is B, obviously. C cannot be here, C cannot be here. Where is C in row 8? It must be here. So that's C. So B, well, where's B in row 2? Has to be one of these three, so it must be 6. So B is 6. C is 8. So no 6 or 8 here. That makes this 9, which makes this 7. No 9 here. This can't be 8 anymore. So B cannot be, so this can't be 6. 8 can't be any of these. So it's 3, 6, 7 as a triplet. This must be 5. So we've done that, we've done that, we've done this, we've done that. We did this. This is 99991. This is done. This is done. So it's just this. 8. Okay, so this is guaranteed 8818. That's 25. 32 minus 25 is 7 at most for 2 cells. So this cannot be 7. This is 3, which makes this 6, which makes that 7. Again, 3 for 2 cells, so this must be 4, which makes this 5 and makes this 9. So we have there 4, 8, 12, plus 8 is 20, plus 3 and 1 is 24, plus 8 is 32. So that satisfies that. So now the rest is probably just Sudoku. We have 4 and 8 remaining in column 9. In column 6, we have 2, 5, and 7. 7 cannot be either of these. This can't be 2 or 7, so this is 5, this is 2, and that's 7. Row 5, we have 3, 4, and 8 remaining. 3 can't be here, and 4 can't be here, so this must be 8, which makes this, not that one. This one, 4. This one, 8, and this is 3 remaining. In box 4, we have 3 and 5 remaining. 3 can't be here because of 3 in the column, so this is 5 and 3. That leaves in row 4 the remaining digits of 4 and 6. 4 can't be here because of 4 in the column, so that's 6 and 4. Remaining digits in column, this can't be 3 because of 3 in the column. Remaining digits in column 5 are 3 and, I don't know, 3 and 9. So this is 3, that's 9, because this can't be 3 here. Remaining digits of row 2 are 2 and 8. 2 can't be here because of 2 in the column, so that's 8 and 2. Remaining digits of column 1 are 2 and 9. 2 can't be here because of 2 in the row, so this is 9, that's 2. Remaining digits of column 3 are 4 and 7. 4 can't be here because of 4 in the row, so this is 7, that's 4. 7 eliminates 7 here, so it's 8 and 7. That leaves this as an 8 and this as a 5. And that's a solution. Very cool, actually. I really enjoyed this. It was a very interesting logic in the restrictions that were forced on us, right? And it flowed very well all throughout. So it never felt like it was stuck with anything, right? So it was basically that because the circles had to have different digits, we knew each of them had to correspond to each of the gray background paths. And so this had to be part of a circle, and this had to be part of a circle because of that. And you could only teleport once here, you could only teleport twice here, with this being 6 and 12 in total value. And it requiring a circle at the other end of one of them. So very cool though. I really enjoyed these black hole and white hole teleporting puzzles. It's very interesting how they interact. Of course, you had the 36. You had the different types of teleportation so that you could get enough teleportations. So there was that too, and that figuring that out was a pretty joyful thing to do. So that was fun. Anyways, I hope you enjoyed this episode of this solve. This is not an episode of Learn How to Sudoku. This is definitely not very easy. And I'll see you next time on Frank Puzzles. Take care.